So, I'm Shelby Allen, and today I'm here to talk with you about the Penzias and Wilson's radio telescope. What were we trying to do? A great question. The project was initially created to make masers, which for anybody who doesn't know what masers are, they're microwave amplification by stimulated emission of radiation, which that's why we call them masers. We wanted to amplify and measure radio signals from space between galaxies using these, and we ended up with the Hold'em antenna, which is over in the Bell Labs in New Jersey, and we used them to sort of try and get this radiation signal, but we ended up having this background noise that we figured was created from the telescope itself. But after extensive testing, we were able to rule it out. We really didn't have any explanation for what it was. But the researchers who led our team were able to create a theory that explained this phenomenon, that the radiation was most likely due to residue left from some kind of cosmic event, such as the Big Bang Theory. This was a huge leap forwards for the scientific community that led our actual team scientists to go on to win the Nobel Prize. I kind of spoiled that. The project took place in Bell Labs in Holmdel, New Jersey in 1962, although the initial team that we all were a part of began to assemble between the years of 1958 and 1960. Other things big happening that year. Well, the Cold War seemed to be the biggest issue with doing scientific work in 1962. Definitely put a damper on things. The radiation from all the nuclear testing was actually one of the initial causes that we theorized for the background radiation, but it was later dismissed due to lack of the decrease of signal over the years, which would have happened with the decrease in nuclear activity. Lead scientists for the project, there were two of them. One was Arno Penzias, who was a German-born radio astronomer, as well as Robert Wilson, who's an American astronomer who kind of held the same interest in the project. Arno joined our group in 1958, and Wilson joined in a few years later in 1960. My role, wow. I was actually one of the scientists who was tasked to rule out all the other things when we first got these initial radiation signals. We had a lot of us that had to try out all the different things that could have caused this that wouldn't be explained by some new phenomenon. We had several theories. One of them was that there was an urban sort of interference from cities, because there's a lot of electrical devices and radio devices in a city. So we pointed the antenna at New York City itself, and we didn't really get anything, not what was actually being seen. So we ruled that out. Then we checked all the components on the machine itself to see if maybe there was something inside of it that was causing this signal. Nothing really seemed out of order, and it wasn't really anything that seemed to be the same radiation signal. We even tested, now this one's funny, we even tested to see if it was the pigeons that like to hang around our antenna that caused this, because we had, it's New Jersey, there's a pigeon problem. We tested to see if it was maybe them themselves, or maybe the droppings on the radio dishes. So after days of cleaning out the droppings off of the dishes outside, we were able to test that, and it was so nasty but necessary to rule it out. We found nothing and reported it back to the project leaders. And then I already told you about the radiation from the Cold War, which was also not an issue that we found. What impact did we have? Well, I'd like to say a big one. It was actually a big stride towards the acceptance of the Big Bang Theory, which wasn't widely accepted, but it is one of the leading theories right now to explain the creation of the universe. Was it controversial at the time? Yes, actually, it really was. Controversial at this time, especially within our own staff, actually. One of the lead researchers that I told you about, Robert Wilson, he was actually a project head. He's a strong believer of what we call the state theory before this experiment. The state theory states that the universe is without a beginning or an end, meaning that, you know, this new data didn't exactly fit in because it showed there is a possibility of a beginning to the universe, which, as said, would disprove the state theory, and that was closely held by Robert Wilson at the beginning. He was actually even reluctant to come to that conclusion when presenting the data to the scientific community and when they published their book a few years later. But they kind of just stated the facts and let people make their own decisions. People actually had come across this before, but had dismissed it due to believing in the state theory. It is a much more widely accepted theory nowadays. Now, I'd like to thank you so much for allowing me to talk with you today. It's been a wonderful experience. Hopefully everybody has learned something more about the project today.